Example 4, we're going to graph rational expressions. So in order to find the vertical asymptote, you're going to set x plus 3, the denominator, equal to 0. So subtract 3 from both sides. So my vertical asymptote is going to be at x minus 3. So just like I did, that's a vertical asymptote. And now I'm going to find the horizontal asymptote, so I'm going to look at the leading term of both of my polynomials. So I have 6 on the top, and then I have x on the bottom. So this is a coefficient, and then this is a variable, so I can't relate them because they're not the same thing. So I have to make them more similar, so I'm going to put x to the 0 power on top, and then x to the 1. Because remember, x to the 0, anything to the 0 power is still equal to 1. So if I have 6x to the 0, that's 6 times 1, which is still 6. And so since they both have a variable, now I can relate them. And then the exponent on top, which is p, is less than the exponent on the bottom, which is q. So since p is less than q, that means I'm going to have a horizontal asymptote at y is equal to 0. So I'm going to draw that in. Okay. Now I'm going to figure out where my graph is located. So I'm just going to pick points. So I'm going to look where my vertical asymptote is, and I'm going to pick points to the left of it and then points to the right of it. So I'm just going to randomly pick a number, and I'm going to pick -9. So I'm going to plug this x value into my original equation. So I have 6 over -9 plus 3, which is 6 over -6, which is -1. So when x is -9, y is -1. So I'm going to go ahead and graph that point right here. So I'm going to pick one more point in this to the left of my vertical asymptote. So I'm going to pick -4. And I'm just going to write in that next box so it's not all crowded. So then I have 6 over -4 plus 3. So I have 6 over -1. So that's -6. So when x is -4, y is -6. And then I'm going to go ahead and connect my dots, and it's going to look something like that in blue. Okay, now I'm going to do the same thing for the right side. So I'm going to find my y-intercept, so I'm going to set my equation equal to 0. So I have 6 over 0 plus 3. So that's 6 over 3, which is 2. And then I'm going to pick one more, and then I'm just going to randomly pick 9. So I have 6 over 9 plus 3, and that's 6 over 12, which is 1/2. So when x is 9, y is 1/2. So then I know it's going to look something like that. Okay. And you should know that there is no x-intercept because the horizontal asymptote is there. So now I'm going to move on to example 5. I'm still going to find the vertical asymptote. in the exact same way I did example 4. So I'm going to set the denominator equal to 0. So x minus 3 is equal to 0. So I'm going to add 3 on both sides. So x is equal to 3. So that means I'm going to have a vertical asymptote on top. Okay, so just to make sure that this is an infinite discontinuity and not a hole, I'm going to also factor the top. So that's x minus 2 and x minus 5. So since none of the factors cancel out, it is in infinite discontinuity. So that means it is a dashed line. So now I'm going to find the horizontal asymptote. So I'm going to look at the leading term on top and the leading term on the bottom. So I have x squared over x, and since the exponent on top is bigger than the exponent on the bottom, that means there's going to be no horizontal asymptote. So I'm going to put none, which means there's an oblique or a slant. So in order to find that, I have to use long division, or you can use synthetic division in this case, but I'm just going to use long division. So I have x squared minus 7x plus 10. So x times x will give me x squared. Negative 3 times x is negative 3x. I'm going to subtract these two quantities. So x squared minus x squared is 0. Negative 7 minus negative 3 is negative 4x. Then I'm going to bring down this plus 10. So x times negative 4x, or x times negative 4 is negative 4x. Negative 3 times negative 4 is positive 12. I'm going to subtract these two quantities. So that's 0. 10 minus 12 is negative 2. But remember, your oblique asymptote is whatever equation is right here. So that is my... Now I'm going to graph it. So remember, this is my y-intercept, so that's where I'm going to start on the y-axis. And then my slope is 1 over 1, so I'm just going to go up 1 over 1, up 1 over 1, up 1 over 1 to graph my line. And remember, slant has to be slant, so that means it's going to have some kind of slope. So it's not going to be a horizontal or a vertical line. Okay. So now I have to graph, so I graphed my asymptotes, now I have to actually graph the rest of the graph. So I'm just going to look at my vertical asymptote, which is the purple line. I'm going to pick points to the left of it and points to the right of it to see where my graph is going to go. So I'm going to first find my y-intercept, which is probably my easiest. So if I put 0 in for all of the x's, so that's 0 squared, sorry, the little 2 got weird, times 7 times 0, plus 10, all over 0 minus 3. And I guess I'll fix that little 2 there so it looks a little bit better. So 0 squared is 0, negative 7 times 0 is 0, so we just have 10 over 0 minus 3, which is negative 3. So if I do 10 divided by negative 3, that's going to be about negative 3 point something. So I'm just going to put it like in this area right there. So now I'm going to pick another point to the left of the purple line, and I'm just going to pick a positive 2. So I'm going to plug in 2 for all my x's, so I have 2 squared minus 7 times 2 plus 10 all over 2 minus 3. So 2 squared is 4. Negative 7 times 2 is negative 14 plus 10 all over 2 minus 3, which is negative 1. So 4 minus 14 plus 10 is 0 all over negative 1, which is 0. So that's 2 comma 0. So it's going to be something like that. Oh, so now I found my x-intercept by accident. There we go. So my graph is going to look something like that if I connect the dots. Okay, now I'm going to do the same thing. So I'm going to take my vertical asymptote, and I'm just going to pick points to the right of it. And I'm just going to pick 5. And it's just a random number. So I have 5 squared minus 7 times 5 plus 10, over 5 minus 3. So I have 5 squared, which is 25, minus 7 times 5, which is 35, plus 10. All over 5 minus 3, which is 2. So 25 minus 35 plus 10 should be 0 over 2, which should be 0. So I found another x-intercept. And then I'm going to pick one more point on this side, and so I'm just going to pick 9, and I'm going to do it, I guess I'll just do it up here because I'm running out of space. So if x is 9, y is going to be 9 squared minus 7 times 9 plus 10 all over 10 minus 3. So 9 squared is 81. Negative 7 times 9 is 63. Plus 10 all over 7. (81 minus 63 plus 10) is going to be 28 divided by 7, which should be 4. So if x is 9, y is 4. So it's like right here. And then if I connect the dots and then keep going and then use my asymptotes to find the general shape of my graph, I should look kind of like that. Okay. And so now I'm going to do the last one, example 6. So if I'm going to first find my vertical asymptotes, so I'm going to set my denominator equal to 0, so I have x squared minus, let's try that again, minus 2x minus 8 equals to 0. So I have to factor it, so that's x minus 4 and x plus